Hi, this is Lori and welcome to my series on the Pico W. This is part 4 of the Exploring LED Displays. In this episode we're going to use a shift register, 74HC595, along with our LED bar graph. The 74HC595 shift register, as you can see a picture one here, is a dual inline package with 16 pins. And it's called an 8-bit serial input, serial or parallel output shift register. And it can be used for a lot of different purposes, but we're going to use it to expand the number of I/O pins we have on our Pico. And we'll be sending in data to this serial input pin, highs and lows, zeros and ones. And then that data will be propagated through these parallel output pins, QA all the way down to QH. Now let's talk about the pinout for our shift register. I have a diagram of the pinout over here. And first thing I just want to point out is when you use these chips, you'll notice there's a little notch on one end or the other. And that just tells you where pin 1 is. So to the left of the notch is pin 1, and then it's numbered down, over, and around. Now, a couple pins we can kind of knock out real quick. As the power pin at 16, we'll connect that into a power rail on our breadboard circuit. And pin 8, we need to connect into the ground rail on our circuit. Now let's talk about the rest of the pins. Well, we have the parallel data output pins. They're at pin 15 for QA and 1 through 7 for QB through QH. So those are our 8 output pins, and we'll connect those up to LED segments that we want to control, turn on and off. So we'll be able to do 8 of them with one of these shift registers. The next pin is pin 14, which is the serial input pin. This pin will connect up to a GPIO pin on our Pico, and we'll use this pin to send in the zeros and ones to our data output pins so that we can turn on and off the LED segments. And we'll go through a demonstration, but as we put in a number here on the serial input pin, so for example we set that to low, then we're going to have to tell the register that we're ready, that we've sent the signal. Please take that signal and put it in the first out pin, QA. So if I sent into 0, it would go here into a spot that's called the storage register. So the pin itself is not set to 0 yet. It's just in the storage register, sort of next to the QA spot. And as we send another one in, then the one that's at the QA slot will move to the QB slot, and the new one will come in at QA. And so it sort of propagates through these. As we move each one in, we move everything down, shifting the bits. I guess that's what we call it, a shift register. So we have a storage register, kind of this memory, this imaginary memory, I guess. And then we have a way to tell the chip when it's time to turn on those pins and give them the data that is in the storage register. So the next pins that do all that are these 2 clock pins. So one is the shift register clock at pin 12, and the other one's the storage register clock at pin 11. Now and both of these will need to connect up to pins on our Pico. So as we set the serial input pin to a 0 or a 1, we then do something called ticking the clock to say, hey, shift register, we've set the serial input pin to the value we want. Please put it in the storage register. And by ticking the clock, we tell it, go ahead and do it now. And then it'll say, oh, okay. I see that the serial input pin is set to low, so I will put a low in the storage register for QA. And then if I put another one in, say I send a high signal on the serial input pin, I tick the clock, that one would then go next to QA, and the 0 that was previously there would get pushed to QB, and it'll keep pushing them down As long as we keep kind of ticking them in, it'll keep shifting the bits down through these 8 parallel data out pins. And we'll demonstrate that a little bit more later. So that's ticking the clock with the storage register clock. So that's how we kind of add in all the data. And then once we're ready to sort of show that data on the data output pins, we do what's called flipping the latch. So we activate the shift register clock and we flip the latch. So we send a high and then a low to do that. That's the flipping the latch and ticking the clock, which is a low to a high. So connected to a GPIO pin for the serial input, connected to a pin for the shift register clock, and connected to one of the pins for the storage register clock. Then in pin 10, we have the shift register clear. So we can clear out the shift register by sending a low and then a high. And so if we connect that to a GPIO pin on our Pico, we can clear everything out and have it all be set to 0 in the storage register. And then the last pin here, I haven't done a ton of experimentation with this, but this is where we can send data out serially out of this shift register. So you remember in the beginning I said it was a parallel output, serial output device. So it can send this data that we've been sending in serially. It can send it back out serially as well through this QH. So we can chain lots of these shift registers together to make many, many digital I/O pins for our Pico. And we'll definitely be doing that in some future episodes. Here's the circuit we'll be using in this episode. We have our Pico here, and next comes our shift register, and you might just barely make out there's a notch here. And so then this is pin 1, which is the QB pin for our shift register. Goes all the way down to pin 8 and across all the way back up to pin 16. Then we can have our LED bar graph with our network resistor, and I just showed the individual resistors here. Now we'll only need 8 of this LED bar graph. We won't be able to use 2 of these LEDs because we only have 8 output pins to connect up to it. So with this particular one I only have 8, so we'll hook up 8 of them. And I'm still using that network resistor. I'm just showing the individual resistors since I don't have a component that works in fritzing for that. Okay, so now let's take a look at how we're hooking up the shift register. So here's the pin 16 that we connect into power, and then pin 8 over here is connected into ground. Then let's talk about QA, QB, all the way down to QH. You'll notice that these are connected into the LEDs on the bar graph. So I chose, how you hook this up is totally up to you and how you want to use it. You can do it one direction or the other. I just chose to put QA here at the last leftmost LED in this bar graph. And then the rightmost one I connected into QH, and so that will matter how you operate this and program it to do the things you want to do. You just need to know how you've organized it, and then you can see that I have all the other ones connected in order. So that's QA, QB, QC, all the way down to QH. That's just how I hooked it up. Now then, the next things that we needed to hook up were the sort of control pins for the shift register here. So you can see, just look and make sure everything, you can see I have the serial input pin connected into the Pico, and these are the 2 clock pins that are also connected into the Pico, and then the clear pin is connected in. And then this is the output enable, which I've connected in to ground so that the data out pins are enabled. All right, so let's talk a little bit more about how the shift register works. All right, I put together this animation to better understand how the shift register works. Now we're going to try to store in this number here where we're going to turn on every other bar in our bar graph. So we need to input these zeros and ones in the appropriate places and in appropriate order for how we have it wired up and so forth. So first thing is I've got a table here which is going to represent the shift register. And this blank row right here will be the storage register, the place where we store the zeros and ones before we send them to the pins, before we flip the latch. And then this row will give us the state of the pin at that point. These little circles here are white, they're LEDs. They'll be the LEDs in our bar graph. It's white if the LED is off, and it'll turn red if that LED gets turned on. So as we start, we're going to send in our first bit, and it's going to go to QA. So to do that, we will need to set the serial input pin to low. So we want to send in this 0. We'll set it to low. And then we need to tick the clock by going low to high for the storage register clock. And that puts the 0 next to the QA spot in the storage register. Now, at this point, we have not shifted it out using the flip the latch. So it's just in the storage register lined up with the QA pin. Now we need to send in a 1. So we'll set the serial input pin to high and we'll tick the clock. And you'll notice that the 0 that was in there gets shifted to the QB spot and the new data point gets connected in or shifted into QA. And now we would need to send in the third one, the next 0. We'll set that to low, the serial input pin to low. We'll tick the clock and we keep shifting the bits over. And we continue this process until we fill up the storage register and with our desired number or pattern, how you want to think about it. And now we want to send that out the pins so that we can turn on or off the appropriate LED segment. So we'll flip the latch pin. So we're flipping the latch. We're going to send that data out to the pins and we'll turn on those that have a 1 and we'll have the LEDs off that have a 0. So that's how it works. When we want to operate the shift register in code, we'll need to use a couple of bitwise operators in MicroPython. And the two we'll need for this episode is the shift right and the bitwise and. So the shift right operator, if we take a binary number, for example, the one we've been playing around with, and we were to shift it right by 1, we will drop off the last place of the number and we would get this number with the 0 at the end missing now. If I were to shift it right 2, we would drop off the last 2 and we would get this number. And if I shifted it 3, for example, I drop off the last 3 and I would get this number. So we'll use the shift right, and we'll also need to use the bitwise and. Now the bitwise and, I'm not going to do a deep explanation. That might be another video. I've been messing around with bitwise operators. They're really quite useful for many activities in hobby electronics. But if I bitwise and a number, a binary number, with the number 1, I will get the data that is in the last position here in the number. So if I take this value and bitwise and with 1, I would get the 0. Now imagine I shifted this number over by 1 and I did that and again, I would then get the 1 that's at the end if I were to do the bitwise and with 1 again. So just one trick that you can use for bitwise ands to pull off the last digit in a binary number. Here's our first program that we'll run, and we'll use it to sort of demonstrate how the shift register works. Kind of like we did in the animation and the slides, we'll do that now with our circuit. I wanted to acknowledge that I borrowed some of the functions from Kevin McClear, one of my favorite YouTubers. He did a video on shift registers in one of his projects, and I appreciate him sharing his knowledge. First thing we'll do is import the machine and U-time libraries, and then we'll set up our control pins. So the serial input pin is connected into GPIO 16. The latch pin is connected into 17, clock pin is 18, and the clear register pin is to 19. We'll set them to low, and then we'll set up some functions to control the shift register. We'll set up a clear function, so we'll be able to clear out the storage register, set everything to lows inside the storage register with the clear function. Then we'll have a tick the clock pin function, where we'll take the clock pin low to high to tick the clock. And then we'll have a flip the latch pin function, where we'll take the latch pin and take it from high to low to flip the latch. And to start off our program, we'll just clear the storage register and flip the latch, so everything on our LED bar graph should be off. Now let's just take a quick look over at our circuit. Here's our Pico. Here's our shift register underneath all these wires, and here's our LED bar graph with the network resistor set up. So you can see all the LEDs are connected back into the shift register, and only the control pins for the shift register are connected into our Pico. So yeah, it looks pretty good. It can get a little messy, and these can be hard to set up and make sure you have them set correctly. So you sometimes have to spend a little time checking your wiring many times to make sure you get this right. And just remember, the way I've chosen to set it up, the leftmost LED is connected into QA pin, and the rightmost LED is connected into QH, and the rest are just in order after that. So that's how I chose to set it up. All right, so let's get going with using it. So now that we have everything cleared out, the first thing we're going to do is send in a 1 or a high, and we're going to set the serial input pin to high. We're going to tick the clock, so that puts that 1 in the storage register. And then if I flip the latch at this moment, the segment that's connected to QA should be set to high, so that LED should turn on, but all the rest of them are still 0. I haven't propagated this number through. I've just done one tick, and I flipped the latch. Then you'll see what's going to happen. Now we'll send in the next 0 into it, and if I do that, send in a low, tick the clock, the 0 now goes to the QA, and the QB, the 1 here, will move over to the QB. So we should see QB turn on and QA go off. Everything else should be off. And what we'll do is we'll just keep trying to push this 1 down the row here by ticking the clock and flipping the latch. But we're only sending lows after the first high that we sent at the very start. So that's all this does, and there's just some delays in here so we can watch it move down the LED bar graph. And then ultimately we'll send in one last, once we get to QH being on, we'll send in another low, and that should turn everything off once we flip the latch. All right, so let's see it run. And yep, you can see it moving down. Getting QH now and off. Yeah, so that's how the shift register works. And now let's move on to our next program. We demonstrated how how bits are shifted in the previous program and with our animation and so forth. But when we're trying to use an LED display, we're really going to want to work with all 8 of those segments at the same time, thinking down the line actually to our 7-segment display too. So we have all 8 of these LEDs in the bar graph connected up to the shift register. So we'll want to put in, binary numbers with 8 places, 8 bits, and then get them all loaded in and then flip the latch. So we want to create a function to do that efficiently, so rather than going piecemeal and moving things down. We'll make a function to handle that for us. All right, so that's the point of this program. It's going to be exactly the same setup as we had in the first one, all the same setup of the pins, and we have all our functions. And now we're going to write a new function where we can write our binary number, our pattern for how we want the LEDs to be on or off on our bar graph. We'll write that number to the bar graph. That's why I called it write num. So I'm just doing some printing so we can see what the binary number looks like and what the decimal equivalent of that is. And then we're going to do a for loop through those 8 bits of our binary number. And this is where we use the shift right and the bitwise and. So as we go through each one, we're going to shift over the I amount and then take that last digit off. We'll look at that bit, that last bit, and if it's a 0, we're going to set the serial input pin to low, and if it's a high, we're going to set the serial input pin to high, and we'll tick the clock and loop back around. So when we start, I is 0, we don't shift at all, we shift 0 places, so we'll get the last place in our binary number. We'll send in the appropriate signal on the input pin and tick the clock. We'll keep doing that until we get through all 8 bits in our number, and then we'll flip the latch. So here's our program. We can play around with a few different patterns to put on our LED bar graph. We'll just clear everything out at the start. And then let's turn on the LED at QA. So we'll send in this binary number and we'll sleep for 5 seconds. We'll clear everything out, have a little pause so we know we've moved to the next step in our program. Then let's turn on what the LED connected to QH. So that would be sending in all these zeros and then a 1. And we'll display that for 5 seconds, clear everything out. And then let's send in our every other pattern. Turning on every other bar. And it turns out that the way this is written doesn't matter whether you send in a binary number to the function. You could also use its decimal equivalent. So this is 170 in decimals, so we can send it in that way, and then we'll end this demo program. All right, let's see this one go. So you can see that's the one on the left next to QA, and you can see what gets written here in the shell, just so you can see each bit as it's going through, what its binary number is, what its decimal equivalent as the bits are done in the for loop. And yep, and there we go. So now we really got some skills to use our shift register. And when you see LEDs all lined up like this in a nice row, the next thing you think about is creating a binary counter. Well, with our write num function, this is going to be extremely easy. The binary counter will be just like the other ones, with all the same setup and functions that we prepared, including our write num function. And now to do a binary counter, we'll just loop through the numbers 0 to 255 because we have 8 LEDs, so we can go that high in a binary counter. And we'll write that number from the for loop to our LED bar graph, sleep very shortly, and move on to the next one. So this should create a nice binary counter on our LED bar graph. All right, let's let this one go. Yeah, it's moving pretty rapidly. I think you can see it advancing there. I wish I had known how to use one of these LED bar graphs when I was doing a bunch of these binary counter homeworks as I've been learning electronics. So yeah, it's really nice for that, and a very compact way to work with a whole bunch of LEDs at once. Well, I won't make you watch all 255. This thing will just keep on going. So we'll go ahead and stop it. And with that, I will thank you for watching.